everyone and welcome to my channel. So in today's video, I am going to talk about the coordination compounds. What are coordination compounds and how they differ from the double salts. And this video is a part of a lecture from my course Concepts of Coordination Chemistry on Udemy, and you can go back and check this course out on my Udemy profile. So let's get started.
Hello friends. So as we are introducing this topic coordination compounds, so let's have an understanding that what these coordination compounds are. So you know about salts in organic chemistry, you know about salts. So what are salts, right? You have learned from very smaller classes about the salts. So you know that when acids and base they react, they form a salt, right? We can just consider an example like we have HCl and acid and a very common acid and a very common base NaOH. So when they react, that's called a neutralization reaction. Acids and base, they neutralize and form a salt, and we get a simple salt like sodium chloride, and water is released. So this kind of reactions you are very well aware. Okay. Now if a solution, just consider this as if we have a solution, right, that contains two or more salts in it, right? So the solution contains salt 1 and salt 2. So any two simple salts which are mixed together in simple molecular ratio that you know as the stoichiometric ratio. So these are mixed, okay? And when this particular solution containing these two salts or more than two salts also is possible, when that is evaporated, right? When that evaporation takes place, then we get crystals, right? Again, solid crystals, we get crystals of salt, right? That salt is regained again, and this kind of salt, they fall in two categories, right? So what are these two categories? One forms the double salt, that can be categorized as a double salt, and another kind of compound that may be formed are the coordination compounds. Now we will see the difference between these two, double salts and coordination compounds. So what are these? Okay, so let's just deal with the double salts. Let's just know what these double salts are. Okay, so we have written the names of two salts. The first one is the Morse salt and the second one we have written as the potash alum. So about these kinds of salts you must have learned in your previous classes. So that's a double salt. So what is a double salt? See, it contains mixture of two kinds of salt, ferrous sulfate, ammonium sulfate, and water of crystallization 6H2O. Similarly, the potash alum contains aluminum sulfate and potassium sulfate and 24 water of crystallization molecules. Okay, so these are known as double salts. Why these are known as double salts? Because they are simple mixtures of two salts, right, in stoichiometric ratios. Okay. Now when these double salts, they are dissolved in a solvent or water can also be a solvent, so dissolved in, let us say, water or any other solvent, then what happens? What we have, they decompose into their components, respective constituent components, right? So constituent components means if we dissolve this more salt in water, then what we will get? We will get ferrous ions, right? And we will get ammonium ions. So ammonium ions, ferrous ions. So there's one iron, so one ferrous ion. Okay, and then there's two ammonium ions. So two ammonium ions we'll get, and then how many sulfate ions? We have two sulfate ions. 2 SO4, 2 minus, and then 6 water molecules. So it will be simply dissociated into its constituent particles. So constituent ions or constituent molecules, whatever it has, it will dissociate simply into its constituent parts. So iron, ammonium ion, ferrous ion, sulfate ion, and water of crystallization. So simply it will just split into its constituent components. This is the characteristic of a double salt. And these constituent components, the ferrous sulfate, the ammonium sulfate, like this, so they will have the similar characteristic of the original double salt. So they will have the same chemical and physical properties. Now, similarly for potash alum also and several other double salts, whatever you know, so many other double salts also. Okay. Now let's just move on to the coordination compounds. So these are the few coordination compounds that I have written here. The nickel compound, then the silver compound, and then the iron compound. So these kinds of compounds, whenever you see, then you get to know these are coordination compounds. So how these coordination compounds are different from the double salts that you have seen just now as written above. How these are different? Okay, these are different because when we dissolve them in water, the same thing that we did for double salts. So when they are dissolved in water or any other solvent, then instead of breaking down into their simple constituents, they get ionized, right? So they get ionized in a different manner. How they get ionized? So we have this when they dissociate, something like this. Similarly for this one also. So they dissociate in a very different manner. As you had seen, the double salts dissociate into their constituent particles or components. So in this coordination compound, the constituent parts are different, right? So it doesn't get dissociate into single nickel ion or single ammonia or the single chloride ions. No, not like this. They get dissociated in a different manner. So this becomes one part, ionizable part, and the other becomes this ionizable part. So these ions that you see attached with the metal, that are complex ions, right? So that is why these are known as the coordination compounds, as well as another name is the coordination complexes, right? Coordination compounds or coordination complexes, because they form a complex kind of arrangement with the different metal ions. Okay. So one thing I missed, we have 2Cl here. This dissociation, we have 2Cl, not a single chloride ion. We have 2Cl here. Okay. Okay, so let's just take this example as the complex coordination complex. So this kind of compound K4FeCN6, right? Okay, now this is obtained, as you can see, I have shown with the arrow, that when we react iron cyanide and potassium cyanide, so two salts, they are reacting and producing this kind of the coordination complex, right? Now when this complex ionizes, so when dissolved in any kind of a solvent or water, then this ionizes as like this. So this is what we get. So here what we are not getting simple potassium or a simple iron and simple cyanide ions. We are getting a complex ion, right? We are getting a simple potassium ion, and this is the complex anion. So -4 charge is there. So we will call it an anion, and this anion is a complex anion, right? Okay. So we can see that coordination complexes, they do not dissociate in their simple constituents. The simple constituents are potassium, iron and cyanide in this complex, but it doesn't dissociate like double salts. This is a simple cation, right, and a complex anion. Similarly, we can have a complex cation also, right, and a simple anion. Like this also, this dissociation of any other coordination complex can also happen. So here we have the dissociation will give us a complex cation or an anion. So that is why these coordination compounds are different from the double salts that we had seen. And now why they are named as coordination compounds? So why? That's because if you look at the bonding, this bonding between the species in the coordination complexes, that involves the coordination bond or the dative bond. You know about the dative bond or coordinate bond. What happens in the coordinate bond or the dative bond? It is also a kind of covalent bond, right? But in this covalent bond, the sharing of electrons between the two species like atom A and atom B, they are sharing this pair of electrons. That electron is contributed only by one atom, and the second atom has no contribution at all. That means one of the atoms is electron rich, that acts as the donor. So donor can be an electron rich species, or it can contain a lone pair of electron also if it is neutral. Okay, and the other atom, as I have written here as B, so this one is electron deficient. So it has lack of electrons, so it wants electrons, and that is why this is electron deficient species is known as the acceptor. Like you had seen in case of when you had studied, you must have studied about the coordinate bond, and a very common example that we encounter is the ammonium ion, right? So here we have ammonia, simple ammonia molecule, where we have what? We have this lone pair of electrons on the nitrogen atom, right? And when the H plus, the proton, reacts with it, then we can depict it as like this. So this kind of arrow from nitrogen to hydrogen, that shows the donor and acceptor characteristic of the coordinate bond. Although when the compound is formed, when ammonium is formed, all the bonds are actually similar. You cannot differentiate between the normal covalent bonds and the coordinate covalent bonds. It is just, this arrow is written to just show that what kind of bonding is taking place on pen and paper. Okay, so this was a quick recap about the coordinate bond. So this kind of bonding is also present in these coordination complexes, where we have a metal atom, right? You can always see a metal atom which we call as central metal, and other part is the ligand, that we will study later on in detail, what are the central metal atoms and what are the ligands. So this metal atom is the acceptor because it is electron deficient. It contains empty orbitals to accept the electron donated by the ligands. So ligands are electron rich, and they donate electrons towards the metal atom. That is why this name coordination compound is arising, because its origin lies in the coordinate bond that is involved between the metals and ligands in case of coordinate complexes. So this was about the very general introduction about what are coordination compounds and how they are different from the double salts, and how they dissociate, and how their dissociation is different from the dissociation of the double salts, and why they are named as coordination compounds. So hope these small things are clear, these basic things are clear, and hope this helps. Thank you.
So I hope after this video you have understood what are basically the coordination compounds and how they differ from double salts. And next we will discuss about the various terminologies that are involved in the coordination chemistry. So stay tuned for the upcoming videos, and till then, see you soon. And please do not forget to like, share and subscribe if my videos are helpful to you. And thank you so much for watching.